hypothalamus is called the master of the pituitary because it exerts a huge amount of control of the activity of the pituitary, both the anterior and the posterior portions. The three main functions from the hypothalamus is to produce and release regulatory hormones, which will either inhibit or release hormones from the pituitary. Another role of the hypothalamus is to produce neurohormones, two in particular, the ADH, antidiuretic hormone, and oxytocin. Where I want to focus right now is on the autonomic centers. Located in the hypothalamus are these autonomic centers that are controlling the sympathetic output to the adrenal medulla. What does that mean? Okay, when you go into fight or flight mode, the sympathetic division of the autonomic nervous system is stimulated, and these centers then release substances that are going to go down to the adrenal medulla, remember the core of the medulla, and stimulate the secretion of epinephrine and norepinephrine. Keep in mind that the epinephrine and norepinephrine are going to do things like increase your heart rate, increase your breathing, increase mental alertness, as well as increasing your rate of metabolism. Looking at the neurohormones that are being produced by the hypothalamus, this includes antidiuretic hormone and oxytocin. They are produced by the supraoptic nuclei. Supraoptic is above the optic chiasm, which is located right here. Also, the paraventricular nuclei, which are located on either side of the ventricle. The cells that are producing these hormones are called neurosecretory cells. They are very similar to a neuron. They have a cell body up here, an axon, as well as a synapse down here with the portal system capillaries. The hypophyseal portal system is very interesting. It does not follow the normal pattern of capillary beds. It is a means for moving hormones from the hypothalamus, not only the neurohormones, but also the inhibiting and releasing hormone. This capillary system consists of fenestrated capillaries. Fenestrations are like little windows. They are huge pores in the sides of the capillaries, which is going to allow the very large hormone molecules to move into the bloodstream. This system is fed by a superior and inferior hypophyseal artery and is drained by hypophyseal veins that then carry the hormones from the pituitary to the entire body. Portal vessels are these that connect the two that we are seeing here, the two separate capillary networks. One of them is in the median eminence here, the other is in the anterior pituitary here. Releasing hormones are going to stimulate the release of another hormone from the pituitary. An inhibiting hormone is going to do the exact opposite. It's going to prevent the release. Some of the major regulatory hormones are growth hormone releasing hormone and growth hormone inhibiting hormone. These two are going to control the activity of the pituitary in secreting growth hormone. Then we have the thyrotropin releasing hormone, which works with the thyroid gland. corticotropin releasing hormone working with the adrenal gland, the corticotropic corticosteroids. GnRH is the gonadotropin releasing hormone. Gonads include the ovaries and the testes, and so this is being directed to the reproductive organs. Prolactin releasing hormone and prolactin inhibiting hormone work with the mammary glands in lactation. The hypothalamus is under feedback control from the body, and it is negative feedback for the most part. The first pattern of feedback that we see over here is very typical of the thyroid hormone that we had talked about. The thyrotropin releasing hormone comes from the hypothalamus, comes down to the anterior lobe, and there thyroid stimulating hormone is released, goes to the thyroid gland, and from the thyroid gland then we get T3 and T4. This is all under negative feedback from various locations. When there is enough TSH, it tells the hypothalamus we don't need any more TRH. When we have enough T3 and T4, it goes back to the pituitary, says we have enough TSH, goes to the hypothalamus, says we have enough TRH. We don't need any more. So then those systems begin to slow their production of those hormones, and the thyroid gland will not be as active. This feedback control mechanism in the middle is showing you how the releasing hormones and inhibiting hormones produce a hormone that is going to act directly on its target. Okay, so here we have the prolactin inhibiting hormone, prolactin releasing factor or hormone. Both of those will go to the anterior lobe. If it's PRF that's being produced, prolactin will be released and lactation will be stimulated. Okay, when we have enough prolactin, then it's going to stimulate the release of prolactin inhibiting hormone, which goes to the pituitary and inhibits the release of prolactin. Prolactin also is going to inhibit the prolactin releasing factor. We don't need it. We have the prolactin, we have the lactation, and so it's time to shut the system down. This third pattern is typical of growth hormone. We get the growth hormone inhibiting hormone or releasing hormone from the hypothalamus, and it again is going to act on the anterior lobe of the pituitary. If it is the releasing hormone, we get the growth hormone, which then is going to either go to the liver or to other target cells, depending on what we need the growth hormone to do. If it goes to the liver, then we are going to get these somatomedins, which stimulate growth of these tissues. Again, you see that we have a negative feedback in that the somatomedins are going to stimulate the inhibiting hormone, and they're going to inhibit the releasing hormone.